Welcome everyone. Today we are going to learn the drawing of geological cross-section and interpretation of geological history of this particular area. So we are going to draw the cross-section along this line AB today. So we have been provided with this map today. First, let's interpret the map. Let's identify the features. So we can see that there are different contour lines. The value of contour line is ranging from 200 to 600. So the minimum elevation of the area is more than 100 meters, in fact feet, but less than 200 feet. And the maximum elevation of the area is lying between 600 and 700 feet. The maximum elevation is more than 600 feet but less than 700 feet because 700 feet value of contour is not present in this particular area. The top of the map, as always, is representing the north. So this direction is north. Now we can determine another direction with respect to the north. So this direction will be east, this direction will be west, this will be south. Now, after seeing the values contours, let's see how many beds are there. So we have 1 trace, 2 trace, 3 trace, 4 trace. So number of beds are defined by the number of traces, unrepeated number of traces. So 4 traces are there. So we are going to count these number, and with the help of that we can determine the number of beds. So we have 5 beds, as we can see from the lithology as well. So number of beds is equal to number of traces plus 1. But what else we can see in this map, that these beds are shifted in one block. This whole area is divided into 2 blocks by a straight line, and these beds have shifted to some direction. So here we have 1, 2, 3, 4 beds. 1 bed is omitted from this particular area, or it is not present over here in this block. So if this is this block X and this is Y, so in block X we can see the 5 beds, and block Y we can see 4 beds. Well, if we have this type of repetition like A, B, C, D, A, B, C, D, this type of repetition is known as acyclic repetition. An acyclic repetition represents the faults. So this particular straight line is representing a fault. We can mark them FF. And because this is a straight line, so obviously this fault is vertical in nature. Because if any feature which is vertical and its trace is present on the ground, that will appear a straight line. For example, this paper is now vertically oriented, and you can see the edge of this paper as straight line. Even in worst cases, if we have undulating topography, so no matter how erosion is there, if we are going to look this page from the top and it is vertically oriented, we are going to see this particular trace. So in case of vertical features, it is going to appear as a straight line only. If you are going to tilt it, obviously because of erosion, this will not appear as a straight line. So because this particular trace over here is appearing as straight line, so this denotes a feature which is vertical in nature. So this fault is vertical, we have interpreted. Now we can see that there are 5 beds, there is a fault which displaces these beds. Let's now determine that what is the hanging direction in the bed. So to determine it, we can take 2 strike lines or same trace, because we can see the same trace is intersected by more than one value of contour line, it means that trace is lying at two different heights. That simply means that particular trace is dipping in nature. So if dipping, what is the dip? What is the direction of dip and what is the amount of dip? So that can be determined by taking two strike lines on same trace. Any of the trace you can choose, and just draw two strike lines, consecutive two strike lines. So this is 200, this is 300. So this strike line value will be of 300 feet and this will be of 400 feet, because this is drawn by joining 2 points on the same trace with contour value of 400. So this is the strike direction. The strike is always in the strike line direction, so this is the strike direction. It means that these beds are striking east-west. So we have strike of beds in east-west direction. Now the dip direction may either be towards south or towards north, but we know that dip is always from higher value of strike to lower value of strike line. It means this is the direction of dip, from higher to lower. So direction of dip is towards south, and we can mention here the dip of beds is towards south. True dip is towards south. Now we can determine the amount as well. But before we proceed to determine the amounts and all, we need to determine the thicknesses of bed. As we can see that this is our section line and all the beds are not coming over the section line. As we can see the bed number, so this is the yanking direction, so we can come to know the bed numbers. This is yanking direction, so younger beds are occurring in this particular direction, means opposite to this will be our older beds. So we can start marking. This is our bed number 1. This will be bed number 2. Similarly, this will be bed number 2. This will be bed number 3. So this will be bed number 3. This will be bed number 4. Similarly here this will be bed number 4. This is bed number 5. 4. This is bed number 5. So we have determined the yanking direction as well. Now we can see that 1 trace, 2 trace and 3 trace is occurring. The 5th is not coming. That's fine. If the 5th bed is not coming, that's fine. We need oldest bed in our section. Youngest may be eroded. But here we can see in this particular block only the bed number 4 and 5 is coming. So in order to draw the bed number 3, 2, etc., we need to determine the thicknesses of bed number 2 and 3. So how we determine the thickness of beds and how we determine through. So if we take the same strike value or same HE and then we keep on drawing, for example, the value between two strike lines is horizontal equivalent in horizontal plane. So this is horizontal plane, so this value is HE. So we can draw different similar values and come to know about the thickness and throw of the bed. So thickness can be determined by drawing strike lines in same block, and throw can be determined by joining strike lines in opposite blocks. So if we draw the strike lines in the same block on 2 different traces of the same bed, we can determine the thickness. So we are not going to consider any other contour line, we are going to follow that particular value of a strike line what we have already drawn. We are going to take same HE for another strike lines we are going to draw, and we are going to follow the pattern as well. So here we have to keep our line parallel to the earlier strike line. Now let's take some more set squares. In order to draw the parallel lines. So this is 400. The next one will obviously be 500. So this is our 500. The next one, here is that point. I have marked through small punch holes by divider. So here is another one. This is one more strike line. So this is actual value over here, and then this one. We have to remove this one. One here, another. So if we need to know the thickness of this bed, we can come to know by seeing different values of strike line. If you see over here, this value is 500 and this is 600. This is roughly passing from the point of 400, so there is difference of 200. So bed number 3 is approximately 200 feet thick vertically. And if you see this particular line for these particular traces, this is our 600, so this will be 700, this will be 800, and this is again intersected by our, this is 700, this is 800, this is 900. So here we have 400 with 500, 600, so they intersected, and it is intersected by 800. So again the thickness of bed number 2 is 200 feet. So we got thickness of 2, we got the thickness of 3. We are already getting the fourth one. So we can determine the thickness of fourth one as well if we draw the strike lines in this direction as well, taking approximately similar amounts. So over here, another over here. So this is roughly passing through this particular point. This line, which is going to be from here, will be having value equals to 200. This will be 200 and this will be 100, and it is intersecting the value of 400. So the thickness of bed number 4, 2, 3, and bed number 4 will be 300 feet. We cannot determine the thickness of first bed and last bed. So now we have determined the thicknesses of intermediate beds like bed number 2, 3 and 4. If we need them, we can further use while drawing the cross section. Another thing, we need to determine the throw direction. It's a vertical fault, so we will have only throw. So what is the direction of throw? We have already learned from the earlier map. If we have got this type of situation, like we have bed number 1 here, 2 here, 3 here and 4 here, and if shifting has taken place in this direction, so this will be bed number 1, this will be 2, this will be 3 and this will be 4. So here the younger beds are coming in contact with the older beds. That direction is our down throw direction. So if we see the younger beds are coming in contact with older bed over here, so this direction over here is throw. So fault, this block has been shifted downward and this is shifted upward. Now let's draw the cross section, and before drawing that, let's determine the dip of the beds first. So in order to determine the dip of the bed first, we'll have to determine the value of HE onto our section line. So this is the value of HE, and if we draw the 0.1 inch on HE, that will be amount of CI. So by drawing the CI, if we join these 2 points, we will get the dip amount for the bed in AB direction, of course. So let's darken it. Let's measure it directly. So roughly the dip is 10 degree. It's not roughly, it is exactly 10 degree. So beds are dipping with an amount of 10 degree in this direction. Of course the true dip will be more than 10 degree because this is current dip direction. The true dip is in north south or south direction, but this is not going in south. So here our dip amount is 10 degree. So we are going to use current dip, that is 10 degree in AB direction, and the dip is from A to B. So dip is from A to B. Now let's draw the cross section. So to draw the cross section, we need to fold this map and draw the profile first. So let's fold the map, orient the AB at their positions. So by marking the A and B, we will get the baseline. So here is our baseline AB. We can mark the fault as well. So I'm writing small f for the fault, and we can mark the position of beds together. So here is bed, and then we also have some contour values. So here is contour value. I'm writing C. I will remove it after drawing it. This is again a contour value C, and here we have bed, writing it as B. This is 500, this is 400, then we are getting one more value, this is 300, this is again 400. We are not getting any other contour values. We are getting 500, 400 and again 400 over here. This is fault, this is bed, this is bed, and again this is bed. 1, 2, 3 trays and 4 trays of the bed. We'll have to remove it anyway, but first we need to draw it. we need to distinguish between beds and contour lines. So this is our AB line. Now in order to draw the profile, we will have to draw the 0.1 inches distance. Since the values are ranging from 200 to 600, so it will be sufficient if we draw only up to 800. So it is 1000, this is 0, this is 0.1, so 0.1 inches will be 100 feet, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, so this is our 500, this is 200, this is 700, 300, 400, 600. Now in this direction as well, we need to do the same exercise. So here is our 500, here is our 1000, this is 100, this is 200, 300, 400, 600, 700, 800, 900. You can mark them. This is 100, 200, this is 300, this is 400, this is 500, 6, this is 700. So fine, now we can mark those heights onto the point and we can remove these values. So this is 500 contour value. First we are going to draw the contour value. So this one is 500, mark it. Then we have 400, 400 as well. Again we have 400 over here. 1, 2, 3 and 4. So then we are getting only 3 contours, and here we can see that after our this 400 we were going to get 500, so this will go from 4 to 5, and here we can see that this 500 was going towards the 600. So here this will join in between 5 and 6. This is 4. This is 4 again, and then this will go in between 4 and 5. So this is our profile that we have got. Now we need to mark the beds. So here is our one bed, here is our another bed, and then we have one bed over here, have one bed over here, and we have a vertical fault over here, so we can directly draw it. Now I'm going to remove the values from in between the cross section. Our dip amount is 10 degree, and we know the dip is from A to B, so we can draw that dip value as well. But before that we will draw the fault, vertical fault. So where is our fault? This is in fact the point of fault. So we have the A along A and B along B, and then we'll get line of fault. So here you can see that this point is in fact representing the fault. Here is our fault. So this is vertical. We are going to draw it like this. This cross section is vertical only. So there will be repetition, acyclic repetition of beds. So this is block A now, and this is block B. Now we need to draw our beds. We're taking the dip amount and directions. So dip amount is 10 degree and direction is from A to B. We will have to plot that 10 degree amount from A to B. This is baseline A, and here we have value. This is 0, this is 100. 10 degree. So take any of the point and draw 10 degree value. So here is our 10 degree value. We have already determined the thicknesses, and of course we can determine the throw as well. So if we see this trace and this trace, this is lying at 300 and the same trace is lying at 600 over here. The value of this particular is 500. So roughly we have 100 feet of throw. So let's draw the beds parallel to this 10 degree line. In order to draw it parallel, we'll have to take help of either another protractor or scale. So these are the point of beds. We're supposed to draw it. We'll not extrude the fault plane, as fault plane always interrupts the feature. So these are the beds we are getting. Now we need to draw this bed as well. We'll have to extend this fault plane above. So here we have got one bed. We will have to draw it parallel. So here we can see that this is bed number 1, this will be bed number 2, this will be bed number 3, and we have small trace of bed number 4 as well. 5 is not presented over here. So here we can see that this is bed number 5 and this is bed number 4. This is 5, this is 4. In fact, we have to look for this. So this is 5 and this is bed number 4. Now we need to draw another beds as well. For that we need the thickness of bed number 4. So we have already determined the bed number 4 is 300 feet. So vertically if we measure the 300 feet over here, 0.1, 0.2 and 0.3. So our bed number 4 will be like this. We can draw a parallel line to this line only. Passing through this point. We have already determined the vertical thickness of bed number 4, so that we are going to utilize in order to draw the another beds. So first orient your protectors, make sure that lines should be parallel, and then move. So from this point we can draw the bed number 4. So here we can see this point is roughly 0.1 inch, so through what we determined is 100 feet only. Then we can measure the thickness of this bed, so this is roughly 200. We can draw this bed again parallel to this one. You need, you can extend it and then this bed. So now we have all the beds. The oldest bed is coming over here. The throw is of 100 feet. So this was our reference line for the angle. We can remove it and we can see that this block has gone down and this block has gone up. So it is carrying the older bed to the lower heights and this is carrying younger beds to the depth. So this is our fault. This is down through direction. Now we can color it so that we can clearly see all the beds. So before we color it, let's draw the section line clearly. This profile and another lines, darken them. So this is our profile. Let's draw the bed. Once we have done the exercise, we can use permanent pens for visibility, but it is suggestible that in file work use pencil only. I'm doing this because of visibility. So this is our fault, the vertical fault. Now we can even remove our baseline if we want. If you want, you can even retain it. There is no problem. Now remove all the other excess informations so that map is clear. So this is our point A and this is point B. I'm just marking some value. This is 0, this is 500 over here as well. This is 0, this is 300, this is 400, this is 500, and this is 600. So I'm marking 6 for 600. Let's write it 600. This is 300. Now we can fill the symbols. So this is again a bed only. So we are supposed to draw this as well. So we can extend and complete this line. Now let's fill the symbols. So symbols are filled like for bed number 1 we have fine dots with purple color. So here you can see in the symbol this is bed number 1. We are getting bed number 1 if we start walking from point A up to some point like here. So 1 is exposed in these regions and it is hidden by bed number 2 in subsurface conditions from here to here. So this is again bed number. We don't know the extent, lower extent of bed number 1. What extent? This is extending below. Let's fill the symbol for bed number 1. The basement is unconformable for bed number 1. Then bed number 2 is drawn by the symbol of bricks. Limestones are drawn. So here we can use that symbols. So this is our bed number 2. This is drawn by green color. So let's fill this color as well. Then we have bed number 3. This is drawn by spawn color. So again we have here the sparse dots in bed number 3. And bed number 4 is represented by yellow color with some fine dots. So here we have a small portion of bed number 4 which is exposed from this point to this point in block A, and block B or block Y, you can see this is exposed from here to here, from here to here. This is colored in yellow. So here we have bed number 4. Then we have bed number 5 from this point to this point exposed here. So this is represented by rather some discontinuous lines. Let's fill this symbol as well. This is represented by spin color in the map. So this is how this area is going to look like if we slice this area vertically from point A to point B. This is of course bed number 4 above. So we can see that this is the map, a faulted region. The strike of the fault is perpendicular to the strike of the bed. So this is in fact a default, you can say. The earlier map we done of fault was a strike fault, because the strike of fault and a strike of bedding plane were in same direction. So this is how the section is going to look like. Now we mention it, cross section along line XY. In fact, this was AB, so we will write AB line. Now let's interpret the geological history. So topography, we have already explained that minimum relief of the area is less than 200 feet but more than 100 feet. So there are 4 points for the discussion of our topography. That is relief. First point is our topography. Second point we discuss is structure. Third point we discuss is order of superposition. Fourth point we discuss is geological history. So topography, as we have discussed, the minimum relief of the area is more than 100 feet and less than 200 feet, and the maximum relief is more than 600 feet but less than 700 feet. We have hill with increasing height towards the north direction. So slope of hill is towards south and dip of the beds is also towards south. Now the structures, so we have 5 beds in this particular region. We have 5 faulted beds, and the bed fault is vertical. Now order of superposition. So in order to draw the order of superposition, what we do, we draw bed number from bed number first to bed number 5, 1, 2, 3, 4. So here we have our bed number 1, we have 2, we have 3, we have bed number 4, and this will be bed number 5. There will be unconformable basement for bed number 1, and then the area is faulted. So what we do, we just draw, it's a vertical fault, perpendicular to it, we write. So here is the order of superposition. Let's interpret the geological history. So bed number 1 must have deposited unconformably over a known basement, followed by conformable deposition of bed number 2, 3, 4 and 5. Then the area must have been uplifted, faulted or tilted and faulted to give rise to present day topography. And after the faulting and tilting, the area must have been eroded to form the undulating topography. So we can summarize, the bed number 1 was deposited unconformably over a known basement, followed by conformable deposition of bed 2, 3, 4 and 5. Then the area was uplifted, tilted and faulted, and of course eroded to form the present day topography. So today we have done this map. This is cross section for this particular map. In the next classes you will be learning some more complex maps with more than 2 structures. Like here we have fault, then in the next map we may have fold, unconformity together, fold, fault, unconformity or igneous intrusions. So we will be doing in order of complexity. Thank you.